Anyone? Yeah, Alex? Number 7. Okay. Number 7. Okay, factoring. Yes, factoring is always a nemesis for a lot of people. So this is on page 1, factoring. So we have 10r to the 4th s minus 25r squared s to the 3rd. Okay, and it says, be sure to show your work. If not factorable, write prime. All right, so when we factor, what are we basically asking ourselves when we start off? Not necessarily what it's equal to, but what's the first thing we're always supposed to be asking ourselves when we're talking about factoring? Greatest common factor. Is there a GCF? So you need to look at your numbers first, and I've got 10 and 25. Now remember, we're talking about factoring, two numbers that multiply to give you those numbers. So what is the largest number that divides into both of those evenly? Anyone? 5, right. 5 goes into 10, and 5 goes into 25. So that 5, I'm going to pull out front. All right, so 5 is my biggest number there. Let's look at the r's. I have r to the 4th and r squared. Now you can't factor out anything larger than your smallest factors, right? In other words, I couldn't factor out r to the 4th here. But what can I factor out? R squared, not 2r, it's a little different, but it's r squared, r times r. So whatever your smallest amount is when it comes to the variables, that's what you can factor out. So I'm going to put this r squared here. And then finally I have an s, and I have an s to the 3rd power. What can I factor out there? Juanita, what do you think? Need some help? Anybody? S, right. An S. Now, if they just asked for the greatest common factor, that's what it would be. But now I need to say, okay, what do I have left? So, got the crud. What is 10 divided by 5? 2. So I have the 2 left over there. R to the 4th divided by R to the 2nd. When you have the same base, R to the 4th divided by R to the 2nd, you keep the base, and when it's division, you subtract. So R to the 4 minus 2 is going to be R to the 2. And over here, S divided by S, those actually simplify out, so I don't have any S's to put there. Then I have my minus sign. 25 divided by 5 is 5. R squared divided by R squared, those simplify out. And S to the 3rd divided by S, that's another one of these. S to the 3rd divided by S. And we could put a 1 on it. Remember that? Like, yeah, unfortunately. S to the 3 minus 1 is going to be S squared. Okay? Any, nothing?
The person that got the keys are not there.
Huh?
The custodian that had the keys aren't there. They're coming.
They are coming?
No, they're coming in my office. I tried to pull it up. Somebody put them here.
Oh. Okay, now, after you do this, you need to look at this and say, is this or some other kind of factoring that I can do? Is this a difference of 2 squares? The answer is no, because 5 is not a perfect square and neither is 2. So your final answer is 5r squared s times quantity 2r squared minus 5s squared. Okay. That was a good one to go over. All right, what else can I help you with? Amaya, do you want to grab a new one from off my desk? I think they're on the kind of over to the right-hand side of the desk. What other ones? Come on, guys. 11. Let's take a look at 11. More factoring. Yes, factoring. Everybody loves it, right? Was there a specific one or just starting on that one? B. Let's take a look at 11B on page 2. Factor and be sure to show all work. If not factorable, write prime. All right, so I have 5x squared plus 14x minus 3. Do I have, first thing you ask is, do I have a GCF? Survey says, no, I do not. So there is not a GCF here. All right, so it has 3 terms and it is 5x squared. It's a quadratic. What's my next thing I should look to do? What should I try next? Does anybody recall? Xbox, yeah. So we can say A is equal to 5. Remember, it's only the coefficients or the constants. B is equal to 14. And C is equal to negative 3. The top is A times C. So 5 times negative 3 gives me negative 15. And the bottom is B. And that is 14. So I'm looking for 2 factors of negative 15 that add to give me a positive 14.
15, negative 1.
Right. You only have 2 pairs, 1 and 15, 3 and 5. And so it's going to be the positive 15 and negative 1. All right, so at this point, we go to the box. Okay. And all of these terms at the top are what goes in the box. So the first box is the first term. Last box is the last term. Make sure you get the sign in front of it to be negative 3. The middle 2 on the diagonal are the 2 that we found here, and you need to add the x there. So that is 15x and negative 1x, because when you add those together, that gives you the middle term. So now we're looking for the GCF of each row and column. Okay, so looking at my first row, let me get a different color here. 5x squared minus 1x. Well, nothing common between 5 and negative 1 except for a 1. I don't really need to put that there. So between x squared and x is going to be an x. Then I look at 15x minus 3. I look at my numbers 15 and negative 3. What's the greatest common factor there? Positive 3. Why is it positive? Because this first term out on the edge where I put these greatest common factors is positive. So that's x plus 3. Now I go in my column. 5x squared and 15x. Well, the 5 and 15, that greatest common factor would be a 5. Good. X squared and x, that would be an x. And then finally, negative 1x and negative 3 would be, looking at the numbers, negative 1 and negative 3. The only thing there is a negative 1. Now, let me go back. It says factor and show all work, if not factorable. Okay, so here are my factors. I am not solving. It doesn't say to solve. It just says to factor. So I put 5x minus 1 times x plus 3. And that, in the blue box, is my final answer. If they did ask me to solve, I would set this equal to 0 and say x plus 3 equals 0, solve for x, and 5x minus 1 equals 0, solve for x there. You would have two answers because it's a quadratic. It's a parabola. Okay? Good question. Other questions? 12A, absolutely. Did we do this one yesterday? I did this one in other classes. Yeah.
We do module 5, we do 2.
Yeah. You'll have to tell me what number, but yeah.
Oh, it's 2.
Okay.
Module 5.
Number 2?
Yeah.
Okay.
Module 5, we take multiple words consistent.
All right, so factor by grouping, be sure to show a work. If not, factorable, write prime. Most of the time, you are going to have 3 terms, a trinomial when you're factoring. However, here we have 4 terms. So I need to break this up into 2 separate by separating the first 2 terms from the last 2 terms, okay? And you are kind of doing them separately. So it's just like before. Look at your numbers. We have a 2 and a 4. What's the greatest common factor there? 2. So divide by 2, factor that 2 out front. Okay, and then look at your variables, x to the 4th, x to the 3rd. The smallest amount. It's like you want to factor out the smallest amount that's common to both. So that's going to be an x to the 3rd. Okay, now looking to see what I have left. So 2 divided by 2, that simplifies out. X to the 4th divided by x to the 3rd is x to the 4 minus 3. Because you're dividing, you subtract, so that is just an x here. Minus, what's 4 divided by 2? Is 2. And x to the 3rd divided by x to the 3rd simplifies out. So that's the factoring for the first 2 terms only. Just the first 2. So now we look at the last 2. I have 3x minus 6. All right, so looking at my numbers, 3 and a negative 6. What is my greatest common factor of those 2 numbers? 3. And it's a positive 3, so I'm going to put plus 3. So we're dividing by 3, and that's it. They don't both have any x's, so I can't factor anything else out. So I put in my parenthesis, I say 3 divided by 3 simplifies out. I'm left with an x minus, and 6 divided by 3 is 2. And you look at this and you're like, hey, I see 2 common factors. Remember, factors are just things that you multiply together. So because that is common to both, you pull that out forward and say x minus 2 times, what do you have left? 2x to the 3rd here and plus 3. So this is your final answer. Another good question. Okay. All right, Daniel, you said, what is it, 2 on the first page?
It says module 5 review, and it says like, this is the bigger the problem, but this is the circle one.
Module 5, number 2. What page is that on for everybody?
3.
Page 3, everyone. Number 2. So this is page 3, number 2. Circles. Use the figure to answer the following questions. Make sure to use the correct notation. And that is very true. So this circle is named what? George? Frank? No.
C.
What is it?
C.
No. It's not circle C. Circle P. You always name a circle with the middle point, the center. So that is circle P. Name a chord. Name a chord. Line segment DE. So DE is correct. And a chord, if you remember, has to have both points on the circle. And we need to put this line segment above it. Okay? It's not a ray. It's not an arc. It's a line segment. Genesis, come on. Genesis. Okay. Name a major arc.
CPA.
CPA. No, that is not an arc. An arc has to be on the outside part of the circle.
Oh, ACB.
ACB is not a major arc.
CAD.
CAD is not a major arc. It has to be over half of the circle. CEB. That will work. CEB. A major arc, and make sure you do the arc symbol above. Jason, come on. Kevin, stay with me. Come on, guys. Has to have 3 points. A major arc has to have 3 points. A semicircle has to have 3 points. A minor arc is only going to have 2. Because a major arc has to be over 180 degrees. Okay? Over half of the circle. So letter G, oh, I guess I'm not going in alphabetical order. How about naming a semicircle?
ABP.
ABP. No, it's got to be an arc on the outside of the circle. Say it again. AEB. That would work. Arc AEB. And again, make sure you show the arc. Morning. Letter B. Name a radius. Line segment PB. Yes. Radius, remember, that's the shorter length from the center of the circle out to the edge. How about a diameter? Line segment AB. You can say line segment. It's okay. If you just say AB, they're usually talking about the length of AB. But yes, make sure you get the correct notation. And finally, give me a minor arc. CA, yes. CA, again, you only need 2 points, and that's going to be less than 180 degrees. Less than a semicircle. A semicircle is exactly 180 degrees. Okay? All right, what other questions? What other questions? Number 1 of the very first page?
No.
Oh,
Page 3.
page 3. Is that module 5? Okay. So it says, and this is page 3 again, line segment JK is a diameter for circle C. Find the measure of BCK. Okay, well, what do we know about this arc? What do we know about this arc, JBK?
That's a measure.
180 degrees.
Say it again.
It's 180 degrees.
It is 180 degrees. Yeah, that is a semicircle. That is half of the circle, right? So if this much is 138 and the whole thing from JBK is 180, how can I find this measure in here, which is the same as the arc right here? Subtract. Yes. So we take 180 minus the 138, and we get 42 degrees. So this arc is 42 degrees, which makes this central angle. Central angle has its vertex at the center. So that is also 42 degrees. That is a central angle. Then it says find the measure of arc JB. So the measure of arc JB is right here, this squiggly line thing. What is the measure of that arc? 138, yes. Because this central angle, JCB, is 138 degrees, that matches up with the measure of arc JB, which is also 138 degrees. So the central angle will always be the same as the arc that it goes out to. Okay? Central angle is equal to its intercepted arc. All right, where would you like to go now? Should we go see the Wizard? The Wizard of Oz? Yes. 19? 14. On what page? 7? 3, 4, 5, 6, 7. 14? This one? Okay. So this is page 7. Number 14. Describe the shapes of the horizontal and vertical cross sections. So this is as if we were slicing these down from the top vertically and horizontally. All right. So let's take a look at number 1. What do we call that figure? A cylinder. So if I were to slice this right here, what would be the shape? If I crack that open, what would be the shape that we would see in that cross section? Yes. So here you would see a circle for the horizontal one. Yes, I know how to spell circle, just barely though. And if I cut this from the top, okay, what is that shape going to be? If I crack that open that way, if I slice it down the center of that circle from the top, a rectangle. Very good. Okay. So looking at number 2, horizontally, if I cut this right here, what is that shape going to be a cross section of? That's going to be a rectangle. So I'm always doing the horizontal one first. And if I cut it from the top, what shape are we going to see vertically as I slice that? Triangle. Yep. All right, a little quickly now. So here, we can't tell that the bottom is a square for sure, but if I cut it right here, I'm going to say that that is a rectangle. Could be a square. If we know this is a square pyramid, we could say a square, but it doesn't tell me for sure. And then if I go from the top, and especially right at the apex, at the very top, that is going to be a triangle. Here I have a triangular prism. So if I cut it here, that is going to be a triangle. If I cut it here, let's say I cut it back here. That should be a rectangle. If I cut this upside down cone, what's that going to be horizontally? Should be a circle. And from the top, if I go from the apex, triangle. And we have our sphere. So sphere, let's cut it right here. Horizontally, that's going to be a circle. And guess what? If I cut from the top, another circle. Okay? Good questions today. All right, so I want you to work on at least one specific part of this. A part that I think it's been a while. Just a minute, I'll come back. So this is chapter 12. I think it is the last 3 pages, chapter 12. And I think it's on quadratics. Okay. So finding the discriminant, how many real roots, looking at this parabola, what are the roots, what is the factored form. I would like to go over all of that tomorrow because it's been a while and I know people usually have problems with this, okay? So the last 3 pages, chapter 12. Please work on that tomorrow. Please continue to work, and I will try to get all the answers, all the work loaded up as soon as I can. Yes. Which one? Go back.
Yeah.
Okay. Let's see what we have for announcements. Did you see? Look at this. Did a nice job on your test. Yeah. I'll take that back after you look at it. All right. Let's see. Guys, keep working hard. There's only 7 days left.